Hey guys, today we're going to take a look at combinations. So combinations is very similar to permutations, and in fact often people use these words interchangeably and are incorrect. In fact, most of the time when you use the word combination, you're probably meaning to use the word permutation without realizing it. So a selection from a group of items without regard to order, this is what's called a combination. So this is I'm going to zoom in because that looks really bad. Combination. Okay, now if it's a selection from a group of items with regard to order, this is what's called a permutation. A permutation. So when we talk about like a combination lock, in actual fact, the order matters when you put your combination into your lock. So it's not actually a combination at all. It's actually a permutation. You're putting a permutation into a combination lock. And so really they're not appropriately named. It should be called permutation locks. So let's take a look at how we're going to use these, or how the difference between them. So in how many ways could Connor, Quinn, Sophia, Patrick, and Taylor fill the position of president, vice president, and secretary? Now this is a question that we've done numerous times at this point. And so all we would do is we'd say, well, that's 5p3. And you could just put that in your calculator and find that it equals 60. Okay? So the question then becomes, in how many ways could these 5 people, the same 5 people, form a committee with 3 people? So you'll notice that at this point, there is no president, there is no vice president, there is no secretary. So in part A, if we had Connor as president, Quinn as vice president, and Sophia as secretary, that would be different than having Quinn as president, Connor as vice president, and Sophia as secretary. So in this case, we're just taking 3 people, and it doesn't matter, the order here. We can put them in any order we want, and it's still the same 3 people just in this group, right? So we're going to list all the different possibilities here. So we could have Connor, Quinn, Sophia. We'd have Connor, Quinn, Patrick. Connor, Quinn, Taylor. We could have Connor, Sophia, Patrick. Connor, Sophia, Taylor. Connor, Patrick, Taylor. And we can have Quinn, Sophia, Patrick. Quinn, Sophia, Taylor. Quinn, Patrick, and Taylor. And then the only one left is Sophia, Patrick, and Taylor. Okay? And that's it. That's all the possibilities. If we don't count order, if we consider it the same 3 people, then regardless of the order they're in, then these are the only possibilities, and there are in fact only 10 possibilities in this case. So if we get rid of order counting, we go from 60 down to 10. So how are these two things related? Well, I'm sure you would never actually just get this necessarily, but what it is that 10 is just 60 divided by 3 factorial. And so what it is permutations. So we'll say I can zoom in again so it's not actually illegible like this, but permutations, we would have NPR is equal to n factorial over n minus r factorial. Okay, that's the one that we have done over and over. And now we're going to look at the difference between combination and combination, which is actually used much more frequently. It's incredibly useful, and it comes up over and over. And so the notation here is we're just going to have NCR, and that's going to be n factorial over r factorial n minus r factorial. So you can see we've got this extra r factorial right there. That's not in the permutation formula. Okay. So a couple things. The other thing I should tell you before I forget to mention this, some books, and you probably won't see this year, but sometimes we'll write, instead of writing NCR, what we'll do is we'll put brackets like this and put NR. And there's nothing in between the N and R. That's how you know that it's not a fraction. It's an N over top of an R. And the way you would say this is, you would say N, choose, whoops, oh my goodness. Try that again. N, choose, R. That's how you would say that. Okay. Oh, so I'm repeating myself here, but so this is just N factorial over R factorial N minus R factorial. Okay. So there you go. And you will notice, likely right beside your permutation button on your calculator, there will be a combination button as well. Okay. So we're going to look at problem number 2 here. How many different sampler dishes with 3 different flavors could you get at an ice cream shop that has 31 different flavors? Okay. So this is how you can see the order in this case doesn't matter if you're just taking 3 ice creams. It doesn't matter, where you're putting them on the dish. It's the same. You're getting the same 3 ice creams. Okay. So this is why order doesn't matter. And one of the most difficult parts when we get further along is you're going to have to be able to distinguish, is order important in this case, okay, or is it not? Because if it's not, we're going to do a combination. So in this case, we're going to have 31 choose 3. Okay, 31 choose 3, which we could write. We could write that as 31 factorial over 3 factorial and 28 factorial. Okay, and so you could put it in your calculator that way, or you could actually just put it in as 31 choose 3. Either way, what you should get is 4,495. And there you go. Okay, so let's look at problem number 3. Each player in a bridge game receives a hand of 13 cards. How many different bridge hands are possible? Keep in mind there are 52 cards in a deck of cards. So for this one, we're just going to have, there's 52 things to choose from. Again, when you're dealing cards in this context, you're getting a hand, so the order doesn't matter. I can shuffle up my hand once I've got the cards. And so it's just going to be 52 choose 13. Okay. And what that's going to give you, it's going to give you a very big number. In fact, it's going to give you such a big number that we're going to write it in scientific notation. That's likely how your calculator will give it to you. So it'll be 6.35 to the power, or times 10 to the power of 11. Okay. And there you go. Now on a test or something, I try not to give you questions that will give you answers in scientific notation, but you never know. Sometimes they sneak in there. Okay, it's not a big deal. You just write out what you see. Okay. Anyway, so Nathaniel runs a small landscaping business. He has 12 kinds of roses, 16 kinds of small shrubs, 11 kinds of evergreens, and 18 kinds of lilies. How many ways can he fill an order if a customer wants 4 roses, 3 shrubs, 2 evergreens, and 6 lilies? Now, again, so there's no order here. If you're just getting a bunch of flowers, you can rearrange them, or I guess they're not flowers, whatever. Okay, so what we're going to do, here, this one, we're going to have to make multiple choices here. So first we're going to have to take a look at the roses. So there were 12 different roses, okay, 12 different roses, and we were choosing 4 of them, okay? Now we are then also going to say that there were 16 shrubs, and we're going to choose 3 of them. Then we have we have 11 evergreens, and we're choosing 2 of them. And then we have 18 lilies, and we're going to choose 6. Now, because you're doing all these things, this is an and question. So you're picking your roses and your shrubs and your evergreens and your lilies. So we're going to take all these answers and we're going to multiply them. Okay, so what you're going to get 495 times 560 times 55 times 18,564. Okay, and if we multiply that, we will get 2.83 times 10 to the 11. Okay, there we go. So the next question is, what if I want 4 different roses or 6 different lilies? So in this case, I'm going to choose my roses. I'm going to say, well, there's 12 roses to choose from, and I'm going to choose 4 of them. The other option we have is there are 18 lilies, and I'm going to choose 6 of them. But in this case, it's an or question. That's what's important. We get this or right here. So remember, when it's an or, when you're doing one or the other, you're going to add your answers. Okay, so we'll get 495 plus 18,564, which works out to 19,059. Okay, there we go. So now we've got a safety committee we're going to make. So there's 15 technicians and 11 chemists. How many different ways can we form a 5-member safety committee if they may be chosen in any way? So in this case, we just say, well, there's 26 people total. Okay, 26 people. And we want 5 of them. Again, you're going to notice we're picking a group. There's no roles within the group. So order in this case is irrelevant. So we're going to have 65,780. Okay. Now, what if it has to have exactly 1 technician? Well, in this case, we're going to choose our technician. Okay. So we could do this as 15 choose 1. 15 choose 1 just works out to be 15, which also makes sense. I would just say there's 15 people. So we're choosing our technician. We've got 15 choices. Now we're going to choose our electricians. There's 11 to choose from, and we need to fill the remaining 4 roles. So it's 11 choose 4. So when we put that into our calculator, we'll get 4,950. Now, what if there has to be exactly 1 chemist? Well, if there has to be 1 chemist, we pick the chemist first. So there were 11 chemists to choose from. And then we're going to choose the remaining 4 using the 15 technicians. Okay. So we multiply that out and we get 15,015. Now, what if we have to have exactly 2 chemists? So this is where it gets a little bit more interesting here. We'll pick our chemists first. So there's 11 people to choose from, and we're going to choose 2. After we do that, we can pick our technicians. There are 15 technicians, and we are going to choose 3. Put that in your calculator. You can just do it in one step. Use brackets if you're having problems getting these answers. And in fact, you should maybe try it out and make sure you do get this. But you should get 25,025. All right. Now, what if it may be all technicians or all chemists? Well, if it's going to be all technicians or all chemists, what we're going to do is we're going to say, well, what if it's all, first of all, what if it's all technicians? So if it's all technicians, we got 15 people to choose from, and we're going to fill all 5 roles. If we're using the chemists, there's 11 chemists, and we're going to fill all 5 roles with them. Because these things are ors, we're going to add them. And we should get, well, we get 3,003 plus 462, which equals 3,465. All right, so now where it gets a little bit more tricky, and this is a great question here, is what if it's at least two chemists? At least two chemists. So this is an example where we're going to do indirect. And a good tip of whether it's indirect is if it says the words at least. If it says at least, usually that means we're going to do indirect. And we've actually done all the calculations necessary for indirect already. We just need to go back and look at them. So first of all, we say, well, what would it be with no restrictions? Well, that was our 26, choose 5 that we did at the very beginning. So let's see, let's just label this. So that's no restrictions. Okay. So there's our no restrictions. And then we're going to subtract the first thing that's not allowed, which was that there were no chemists. If there's no chemists, well, then it'd be 15, choose 5, because it's all technicians. So this one is 0 chemists. All right. And then finally we say, what else is not allowed? You can't have no technicians, but you also can't have just one technician. Exactly one technician is not permitted. Well, that was the one where we said 11 times, and then we had 15, choose 4. So that one there, that right there is 1 chemist. All right. So we started with no restrictions. We say we can't have 0 chemists, we can't have 1 chemist. So this means we'll have at least 2. We could have 3, we could have 4, we could have 5. All of those things are okay. The alternative is you can figure it out with 3, 4, or 5 and add them all up. That sometimes is easier, but generally it's not. Especially, I mean, because this is a 5-person committee, it probably would be about the same difficulty to do it that way. But if it had been like a 15-person committee, that would take a very long time. So usually in these cases, using indirect method is the best way to do it, but not necessarily. And if you don't think to do indirect and you do it the long way, you will still get the right answer. It just might take you a little longer to get there. Okay, so anyway, so we're going to plug in the numbers, and like we say, these numbers all come from earlier. We had 65,780. And we're going to subtract 3,003. And we're going to subtract 15,015. And what we will get is 47,762. And that is our final answer. So there you have it. All right, so until next time, go Sabres.